Okay, so this is problem 10.2.33, and you can't really see it there. I guess you kind of can. I'll read it to you. It says, the problem says, after rolling the first ball of a frame in a game of 10-pin bowling, how many different pin configurations can remain? Okay, and let's just think about this. So I feel like actually I want to write it out so you can look at it. So after rolling the first ball of a frame in a game of 10-pin bowling, how many different pin configurations can remain? Okay, so the way that you have to think about this is you have to think about what's possible for each pin. So you have 10 pins, and if you think about it, I think I'm not very good at, I don't know exactly how they're configured. That's, how many is that? 4, 5, 6, 7, I don't know. So maybe it's 1, and then it's 1, 2, 1, 2, 3, 1, 2, 3, 4. Is that how they're done? This is bowling. I don't bowl. So anyways, if you look at this configuration, you have your 10 pins, and each pin, it's possible for them to either be down or up. So you roll your ball, and it's either going to hit some of them, all of them, or none of them. And so each pin has the potential, because they did say that we want to assume that all configurations are physically possible. Each pin can either have the position of being down or being up. So the way that you have to think about this is pin number 1. If I were to just give myself some spaces here to think about it, pin number 1 right here has 2 options. It can be down or it can be up. Pin number 2 also has 2 options. It can be down or it can be up. And we can do this for all 10 of the pins. So essentially what you're looking at is 2 to the 10th power to determine the possible number of configurations of this right here. And that's because each of these has the option of being down or up, and down or up gives us 2 choices of how they can end up. So 2 to the 10th here, when you multiply that out, will give you 1,024. So there's actually 1,024 configurations possible. Okay.